And so the idea is you'll give it a URL. And so if you do it with this way, where you just have the URL path, it doesn't actually get downloaded to your computer. It's sort of like streamed from the internet into your R session. So there's no file intermediary here. I guess you could either do it where you download the file to your computer to have some file intermediary that then gets read into R, or it goes directly from the URL into R. Yeah, so that's like the actual link. The website link is the CSV. Like the URL link has a CSV. It gets cut off in the slides a little bit. But the idea is like this is a CSV like that sits in this like location on our GitHub page. So it's not like an HTML. So like if it's straight up HTML, like if it's like a home page, there are ways of like parsing that with R, but like that's kind of advanced and outside of the scope of this. This Yeah, that one, if we do it, and you'll see that in the lab in a second, like you can't directly stream an Excel file because it's like this binary file format. So like if you use that one, you'll usually have to save. If you actually use this import option with Excel, it'll basically, if you put a URL, it's not going to work here. And so like, for example, what happens is this code won't work because it can't be previewed. But what's happening is it's like the first command is making a URL, kind of like I just did with my computer, like on my session, and it's saying this is the destination file. And so then the first step is basically downloading that file to your computer with the Excel, or with the way of doing this is Excel, and then it uses the read_Excel on the destination file. So it kind of does it for you if you have an Excel file. So maybe this is an easier way to use Excel, is to sort of throw it in this way, so it gets downloaded automatically to your destination file, and then it's read in. And so then you have the destination file on your computer, and then you have the data read into your R session. Oops. Okay, and so then like what's going on behind the scenes? And so the function itself is either like read_delim is like the main reading function in the reader package. And that requires a file name either on your computer or a URL, a delimiter, which tells you so again how the fields are separated. And then there's a ton of other options you can throw in there that are even beyond like what appeared in that dropdown for importing data. So there's like what's the quote symbol, what are column names? Does that mean like your first row or columns or actually like the headers of the data or not? You can give it explicit column variable types, like you can give it all the classes up front if you want. You can give it like what are the NA variables, what are the comment variables, do you want to trim white space, do you want to skip lines? And then a few of these things also involve basically RStudio tries to be smart, and if it's trying to guess what classes each column are, if you have like a 1,000,000 row file, it only reads about 1,000 of the rows in order to guess the classes for the rest. And so you can change that behavior too. If you have a really big file, there's this progress bar that'll pop up and start spinning saying, hey, I'm processing this for you. And so these are all the things that you can sort of input or change and read delim. And so again, the key is that you basically just need a path to the your file in quotes. If it's on your computer, it's going to look in your working directory if no file paths are given. And again, the file name can just be a path to a file on a website and not a file on your computer. And so the read_CSV function essentially uses that read_delim function in the background, where it assumes that your separator is a comma, it assumes that your first row is a header, and it does a few other steps. And so this is just printing like what the function does, like what the body of the function is. It's just showing the various arguments. So with help, if you actually did want to know how to use this a little bit better, if you're in RStudio, you can say, hey, like I always forget how this works, read_delim with a question mark first. So several things too. You'll note that like with RStudio, if you just sort of hover and don't press enter immediately, it gives you a very brief description of what that function does. And so read_CSV and read_TSV for tab separated values are special cases of read_delim. They're useful for reading the most common types of flat data. And so now if I press enter in my help file, you'll see, hey, this is like the read_delim function in the reader package. And so reads a delimited file into a tibble, which we'll talk about in a second. And so these are just sort of the contents of sort of what each of them are. So all these help files are structured the same way. File is basically the path. Delim is sort of what field separates the values or records. What delineates quotes. And so for each of the arguments, it gives you some details about it. Value is basically what gets returned by the function. And so here it's a tibble. If there are parsing problems, the warning message will tell you how many there are, and we'll show this in a second too. And then there's sort of examples you can run from the example itself. And so if I just take this and I press Control Enter to like send it to my console, it works. And so most of this code is runnable. And so you can sort of see like what you would expect to get back by using their example code to see how the function works a little bit better. And so this is saying, hey, like let's read the CSV file for this example in the reader package. And so you can see this data gets read in. You could have saved it to something and played around with it a little bit. But the idea is it basically just shows you some examples of how you can use the function to do common tasks. It's important to point out, though, that like all of these tidyverse packages have their own better, more detailed vignettes. And so if you go to reader.tidyverse.org, and so actually if you're just at tidyverse.org, let's do this first. This is basically the main core set of a lot of the packages we're going to use in this class. These are our packages for data science. It's sort of a curated set of packages. I guess they call it an opinionated collection of our packages for data science. They all share an underlying design philosophy, grammar, and data structures. So if you want to install, I believe right now there's 8 packages that are default. There is ggplot2, dplyr, tidyr, readr, purrr, tibble, stringer, and forcat. So if you install that package as tidyverse, all 8 of these get installed by default. And the reader one is basically the one we're talking about right now. And so on this website, there's way more detail than like a help file. And so this gives you examples how to install it. It gives you examples there's a whole cheat sheet for it. And so this is like a 2-page thing, double-sided. You can print out and like put next to your computer if that's something, if you're always like, hey, I forget the exact ways of doing this. How do I do that? It basically has, read tabular data. It shows you like a rough, little cartoon of what your data looks like. And then like the corresponding R code to turn it into a rectangular file format. Talks about useful arguments like skipping lines, or reading in a subset of data, or how to handle missing values. It talks about how to read a non-tabular data, and then like details on data types, and then which we'll cover tomorrow later in the class, ways of like reshaping your data, splitting data, expanding data, handling missing data, etc. And so here, like the usage has a bunch of examples for how to run it. I believe like in the overview tab, there's even more stuff here. And so there's a lot more detail than you would get from just like the R help file by like looking at these, like they're called like vignettes. So they're like way more detailed descriptions of how the functions of these packages work. And so now if we wanted to use the command line to do this instead of that dropdown, R uses these relative paths. So I'm going to say read_CSV. And so I'm saying wherever I am right now, go up a level and go subdirectory higher, and go down into the next one, data, and then that file is in this data folder. And so if you know where you can find the file on your computer, you can sort of just give it the path to the file itself. And again, you can still use the data dropdown, the data import dropdown as you get more comfortable navigating sort of the file structure of your computer within R itself. And the idea is like you'll get these messages and the data is now successfully read into your R workspace, just like using the drop-down menu. So again, some common user mistakes is like these working directory problems. R is trying to read in files that it can't find. And so again, RStudio can help with this, and so can using RStudio projects. Typos are also an issue, although I'd say working directories is like the #1 issue for like trying to figure out why you can't read in files. It gets a little bit confusing too when using R Markdown, where you can have an R Markdown document open in one location and then like your console's in a different location. and you're trying to send code back between the two to like test out your R Markdown document, that's one really common way of like running into these working directory issues. And so it's just important to like just know where you put the file and how to point R to like find the correct file. And so again, R looks for these files relative to this working directory. And then many people recommend not even explicitly setting a working directory in your scripts because it assumes you're in the directory the script is in. And if you just like open a file on your computer, like an RMD file or a .r file, and RStudio is the default program for opening it, it'll usually open the R file with the working directory set to that location automatically. And not setting working directory is good too if you're sharing the script with somebody, because it's really unlikely that the person you're giving it to is the exact same directory structure that you do, because you'll have a different like username, so that won't be the same. And so if you do want to set it explicitly, you should do it at the very top of your script. And so some functions for like looking at working directories and setting them involve the get WD function. And so this will return a character vector for where I am on my computer. The thing I'm in users, Andre. Whenever I made Windows 10, I wrote Andrew Jaffe and I chopped it to Andre. It's like, and you can never change that. Go to Windows, Documents, GitHub, enter R data classes. And so that's like the full path to the file on my computer, to the location of where my R is looking on this computer. If I wanted to change this, I could set the working directory to be a different file path, but you note that it has to be an actual path. So if I try to do this, it'll say, hey, I can't change the working directory, and saying it can't change it because that location doesn't exist. And so you'll get errors when it's not a location on your computer that can actually be accessed. And so setting the working directory can sometimes be finicky. You can see it, for example, here. Default directory structure in Windows is a backslash, a single backslash, but R interprets this as an escape character. So you have to basically replace your backslash with forward slashes or two backslashes. You can see how it's already affecting like the actual text here. So for example, like if I open a location on my computer and like I click the top, you can see it goes C users, backslash Andre, etc. And so this you can't, R does not like this by default. So again, this is only a Windows issue. So again, if I wanted to set the working directory to this, it's saying, you get this weirder thing saying, hey, this U uses the hex digits and character string starting CU. It's because this is an escape character, not a backslash. Again, it's like a special Unix Linux thing. And so here I'm basically escaping one of the quotation marks. And so like the backslash doesn't even appear because of how the text is sort of interpreted by R Markdown. And so your typical directory structure for Unix applies, where ... goes up one level, / is the current directory, and then this tilde, which is next to the 1 key, is your home directory, and that's like a special thing that like your computer defines. Windows, it's like users, home, my documents, or something. For Mac, it's however it gets set as the default. And so then like another way to look around is some directory navigation. Once you're like within a working directory, the dir function interfaces with your operating system. It shows you which files are there. And so if I do dir of this, all the files that are in this location are data.io HTML, data.io PDF, etc. If I do dir ... that means like, hey, like what's one level up on my computer, like what's present there, and it'll list all that out. And so this again comes back to these relative versus absolute paths. So an absolute path points to the same location in a file system, regardless of the working directory. Here you have to give the whole location. And so again, this is maybe bad for R because like if you give it to somebody else, it won't work because it's not the same structure as your computer. A relative path starts from some given working directory, avoiding the need to provide a full absolute path. So for like R Markdown, you probably, if you're going to share your RMD, you probably don't want to use absolute paths because they won't be able to knit that document. So again, if you want to set it with like sort of drop-down support, there's also an option here too. So in RStudio, if you go to Session, Set Working Directory, there's several options. One is the source file location, so that's like whatever file you've opened, it'll set the working directory to that. There's also a separate files panel here. You can sort of hit that one, or you can just manually set it yourself. Or if you say choose directory, oops, you can just sort of navigate on your computer. I don't know why that didn't work. You can just navigate on your computer to a location. So let's say this, and I can hit OK, or I hit open. And so now it shows you the code you would need to like do that again. And so again, then you would go back to your history and probably copy that to your script. To source. And so that would be how you can basically like use a little bit of support to search for it on your computer and then get the code to do it automatically for the next time you open the script. And so with RStudio being the default to open things, you should always get opened. If you open an R file within a new RStudio session, it should automatically set the working directory. In order to set the RStudio to open R scripts, hopefully it does it for you the first time you install it. On a Mac, you have to right click, get info, and open with RStudio, and then change all, so it does it for all files. On Windows, if you're in a location, you can like go find, if you go find a script, you can like right click it. Here's an R file. You can right click it, say properties. Oops. And so like one of the defaults is opens with. You can hit change, and then you can click RStudio and hit OK. And so that's another way. That's how you would change it. I think things like RMDs always default to RStudio, but R files maybe sometimes get opened by your text editor by default. We just showed this, but so like for any function, if you write question mark function name or the function help, and then the function name in quotes, that'll help you look at the help file. And so I just showed that for readr, so I'll skip this. So one of the things that comes up sometimes is if you were to read this in, it does check for problems. And so here it didn't look like there were any problems. And so there's this problems function and spec function. And so if I say problems of that, it's saying, hey, we didn't find anything. There's no problems. What'll happen is sometimes there's weird parsing errors where maybe it's expecting like 6 columns, but then like a 7th column appears in one of the lines. It'll flag that for you here. And so then you can like go back, check the underlying data. Maybe like a setting wasn't correct for how you're interpreting how the data is being read in. Then, so if you get problems and you're not expecting them, it's usually a good time to like stop and like check to make sure something's not wrong with the underlying data. The other thing you can see is like you get some of the information of what all the columns were that got read in. If you type spec and then the object name, it shows you the entire specifications for how it was read in. And so this also lets you sort of quickly check to see if there's maybe, especially if it gets parsed weirdly, if there's something not being treated quite correctly. And so there's this stop for problems function that'll stop if your data had an error when reading it in. And so you can either manually set the column type from using the output of spec, or you can try to, sometimes maybe the first few columns have some problems or don't have problems. And so if you don't try to guess the class for like a very small subset of the data, it'll take longer, but you'll probably be more likely to be accurate. And so then, regardless of once you assuming you get it in with no problems and maybe you change some stuff that you had to, what happens is you'll run this function. It'll our object will get read into your environment, and then you want to start doing analysis. And so what comes in is this thing called a Tibble, which is a special data frame, which is special because it has special printing and special attributes. And this is the primary data format for most data cleaning and analyses, especially in this sort of tidyverse landscape. And so Tibbles are, so if you use read.csv, which is like the base R way of reading in CSVs, that returns a data frame. If you use read_CSV, which is the reader implementation of importing CSV files, it returns a Tibble, or TBL, we sometimes say. And so Tibbles, if you read this in, there's several special attributes with how they print things. And so, for example, if I say dat, it'll only print the number of columns that will fit on one screen. And so if I just type dat, it's going to only print 10 rows, and then only, in this case, 4 columns. It's, even though it says there's 9,700 rows and 31 columns, it's going to show these 10 and say, hey, there's 9,784 more and 27 more variables, and then just list out what those variables are. And so, for example, if I make this wider, I run this again, it's going to print more columns this time, because again, whatever your screen is seeing, it's never going to go beyond that. This is different than if I just printed this as a data frame. Here, it's like it prints like 32 rows because it ran out of this sort of like max printing option. It prints each of the columns. It's sort of harder to see, you know, like, so this first row is like this row, and then like the next columns are in this row, and the next columns are on this row, etc. And so the Tibble kind of avoids having to like scroll down a bunch of rows to see like what all the data is for that particular column or for that particular row. And so that's one thing, nice thing about the Tibbles. There's another one too where like a Tibble can have one column, whereas data frames, when you start subsetting, can't just have one column, basically. So those are the two main differences. One is sort of controlling how it gets printed, and the other one is sort of just like how data frames get returned or how Tibbles get returned when doing operations to them. But that'll become more apparent in a little bit. So once you've read in a data set, or an R object, a Tibble, or a data frame, there's these sort of helper functions for just quickly glancing at the attributes of it. And some of the more useful ones are nrow. That'll tell you how many rows there are. Ncol will tell you how many columns there are. The dim function does both. It's like a length, returns a length to vector of the number of rows and the number of columns. And then there's also this column names function that'll display the column names. For Tibbles, you can also just use names. And then for data frames or matrices, you can use the row names function. So another thing with Tibbles, our Tibbles never have row names. They feel strongly that if there's actual useful information in your row name, it should just be a variable in the data set itself. And so for what we just read in, we can take a look at some of the outputs of this. Oops. I'll move this over now. And so you can say, like, let's say the dim of the dimensions. Another useful one's glimpse. That shows a little bit more information where it says how many observations and variables there are. It shows you each of the columns and then like what classes they are, as well as the first, few observations in each of those columns. That's really similar to what gets viewed here. If you're in your environment, you'll see there's a little plus sign next to the data sets. If you click that plus sign, it's basically a clicky version of like typing this code, where you'll get each of the columns and what the data look like. Again, you can still use view if you're comfortable with that. Sort of like an Excel spreadsheet style way of just like looking at your data. You can sort things and filter things. You can filter certain columns by certain things. So it's like a lightweight spreadsheet viewer. But we don't really recommend using that for like analysis. It's just good to like check to make sure it got read in correctly if you're going to use it. And so one common task is like maybe you'll want to read in a data set and somebody used really big names, or sometimes names don't get really parsed correctly or as you would expect based on maybe having like hyphens in them or weird variables that R doesn't like. And so in dplyr, there's a function called rename, and this takes the form of you say rename to this tibble or data frame, and then you can just give it in comma separated chunks all the columns you want to rename. So it's saying, let's take the new name, which I'm going to make lowercase year, equals old name, capital, all upper caps year, and then resave the data set as that. And so rename will not return just the column names. It's going to actually make a copy of the tibble that has the new column names. And so this is now the output of this is a tibble, not just a vector of column names that you'll then assign back to overwrite your data set. And you can check to confirm that the column names changed by just running the names function and seeing that, hey, it used to be capital year, now it's lowercase year. So there's a few things to point out. One is that there's no undo function in R. So if you made a typo here and you run this, you can't just like undo it. You'll have to like read in the data set again and like rerun your renaming code again, like without the typo. Two is you can like put a few of these arguments in here. So I could say year equals capital year, comma. I could say like loc desk equals, you can make it smaller. I can put many of these things in here. And so it'll do multiple things in one call without having to use like any logical ands or ors. And so, yep. No, it'll find it for you and just rename anything you put in. It might matter if there's like two names of the same type, but R tries to, when it reads it in, it'll like add a .1, or I'm not sure what exactly it does by default with the reader implementation, but it'll add some additional string that delineates like, hey, this is the first time you saw it, this is the second time, the third time. So the order doesn't matter in the R implementation, but it might matter in how you read it in or how R interprets it. And so this is sort of the first little piece of data cleaning. And so I'll rename data things a lot. I think we talked about this later, but one useful function is like this package called janitor. And so this is especially nice if you get some like random public data from who knows where. This is a way of basically like it tries to automatically relabel all of your column names with something maybe more intuitive. Here's the website. And so I've started using this more and more, especially when like biologists give me things that have like a bunch of units in the column names or have parentheses units or things that aren't nice to be read into R, and things that have spaces. There are a lot of things with spaces or hyphens or underscores. And so the idea is it tries to perfectly format data frame column names. And so, for example, like this is a very common type of like thing you would get from an Excel sheet. First of all, it'll be Excel. It's almost never CSV or text file. It has like a first space name, last space name, employee space status, subject, hire date, percentage allocated, full-time question mark, do not edit. Maybe there's like comments people put. And so how this works is it'll basically try to, there's this clean names function that will try to just like make cleaner names for every single column name you have in a consistent naming format. And this is maybe more of a content for some of the data cleaning we'll talk about later, but I just want to make you guys aware of it. If you have like data you have now that you want to play around with, this can be a useful way of just quickly cleaning it without you having to like manually change each column name or parse things yourself. And again, it tries to always do, like it tries to make either like with hyphens, or sorry, with underscores between them, or like lowercase, uppercase. And so there's different formats of like how people like naming things. You can change how like it names things yourself. Cool. And so while now you've run it in, you can maybe change a column name or two using the rename function in dplyr. It's also nice to be able to like write things out after you finish them. So say like you read your data, you do a bunch of analyses and cleaning, and you want to like save a clean copy of the data on your computer to send to a collaborator. There are some data exporting functions in the readr package, which have the pattern like write underscore something, like write underscore CSV or write underscore delim. And so write underscore delim, you have to give it the R object on your computer, which is the R object in your session, which is X, a path, which is just where you want to save the file to. It could be an absolute path or relative path, and then what the delimiter should be. And then if there are missing variables or values, what do you want them to be called in the corresponding text file? If there's already a file there, do you want to append it? Usually false. And if you are appending it, if you're not appending it, it will make column names. And so this just means not, the exclamation point. And so if append is false, column names is true, and vice versa. And so by default, it will return column names as the first row in your text document. And so other popular delimiters include a comma to make it a .csv, and you can use the write underscore CSV function. And then again, this is some problems we have with the backslash. And so the actual way of doing tab delimited, like this is the symbol for tab delimited. And we'll fix that in the slides. Where it's basically a \t. And so that's saying, this is like a special Linux thing saying, hey, \t is a tab. It's not just the letter T. And so just as an aside, there are similar packages in BaseR to what I just showed you in readr, like write.table and write.csv, which have generally the same arguments but called different things. These functions write out row names, which don't really exist in this tibble space. Sometimes I usually don't write out row names because I usually, like if you have a data frame and you write out a row name and there aren't really row names, it'll make the row names 1, 2, 3, 4, 5, it'll just make them numbers. And if people just open them in Excel anyways, it's weird because the row names are right next to like a label of 1, 2, 3, 4, etc. And so well, we recommend using the write underscore table and the write underscore CSV function. And so in general in this class, for a lot of the content, we'll try to use all this tidyverse style of syntax and functionality, but sometimes we do show you ways of doing it twice in a different way using BaseR. And that's because if you're like trying to Google for an answer after this class is over, a lot of the answers people post online are using like the BaseR syntax and not tidyverse syntax. So we just want to give you exposure to both. Although we recommend using the tidyverse because it's sort of just a little bit more intuitive for new users. So for example, say we rename the year column now into another one saying now it's capital Y, lowercase EAR equals year. And now we have this tibble. I can say, hey, let's write this as a CSV. The path can just be youth tobacco underscore new names.csv. And so that'll get written to your computer with that file name. So that's going to be in your current working directory with that file name. And so the last thing we'll cover is data input using Excel. And so many data analysts collaborate with researchers who use Excel to enter and curate their data. And so oftentimes this is the input data for analysis. You have sort of several options for getting this data into R. Sometimes if they just give you one Excel sheet, you can basically save that Excel sheet as that table or that sheet as a CSV file, and then read it in using read underscore CSV. Or you can read it directly from the Excel with in this case, the read Excel function. Sometimes with single worksheet XLSX files or Excel files, I'll sometimes just save the first spreadsheet because I'll usually open it and make sure it like looks sensible. Because sometimes they'll add a bunch of other summary data too to like, they'll take the means and put them as like a new column. And so I'll just like strip all that stuff off. However, sometimes you'll just put like 50 different worksheets in one file that are all really well formatted. In that case, you can use the read Excel function to read in that sheet and then specify which sheet itself you want to import. And we'll use the read Excel function in the lab in a second. And this is just a resource of other types of formats you can read in. The Haven package, which is also part of Tidyverse, although not one of the 8 formally packaged ones, allows you to read in SAS, SPSS, and Stata data directly. And so, for example, I believe there's also, I guess it's this one. Actually, I thought it might just be haven.tidyverse. And so maybe there's a better URL, would be haven.tidyverse.org. I'll update that too. And so the idea is it can read in these SAS7 BDAT files. It can read these SAS transport files. It can read the SAV file from SPSS or the older POR files. You can also write them out, which may be useful too if you work with people that do SPSS. And then the read DTA and write DTA files allow you to interface with Stata files up to version 15. And so once you use these, they get read in as a tibble like you would for an Excel file or a tab delimited file. These are maybe just more like details for each specific program. They translate value labels into a new labeled class, so you can sort of keep this like metadata in the tibble, but not like directly in the data. And you can read more about that here. It tries to convert dates and times into the more formal date and time class as well. And they show you a few examples for file formats that come with this package for using it. And so again, if you do a lot of SPSS data or SAS work, this is maybe useful, especially if you have like clean data already made from SAS or Stata that's in one of these file formats. You can just read it directly into R with the Haven package. And so this read Excel package is probably like the best way now to read in Excel files. There were a few other ones I listed, but they're sort of antiquated now, especially because there's so much more support for this. Again, the readr package is probably the standard now in Tidyverse. It also is very fast for large data sets. Part of it is because it tries to use this trick of reading in a small amount to guess the classes, and then it applies it to the big data set. There's also SAS7 BDAT, which is just sort of one type of SAS file format. And then the foreign package, it's been around for longer because it kind of came out before this Tidyverse stuff. So there's been more testing, but it's not as maintained because like people are using Haven, I would say, more than foreign. And again, some of these are now available in the RStudio dropdown list. That kind of varies. Sometimes they'll update these like with new versions of RStudio for what gets displayed. So for example, if I go to File, Import Dataset, you'll see now that there are from SPSS, from SAS, and from Stata options. I believe they have just really similar syntaxes to the other types of things. I've never used SPSS, but I assume there's some like model you can say that like a company's data. I guess you can give it to it, and it will incorporate it somehow as I guess that like labeled variable. But again, the idea is you give it the URL or the file name. This is what it gets read into in your R session. This is some optional data. And then like you can also specify if it's SAV, DTA, POR, SAS, or whatever. And so again, same type of syntax. You just have to give it the location of the file on your computer or the intranet. If people have questions, I covered a lot. We didn't really do much practice, so now there's a lab. But before we do the lab, do people have questions?
When I said before, RStudio is not like a drop-down analysis tool. The drop-down for like, reading data in, I think it's really good. That's how I would recommend starting out. It's probably the best way to get data in there easily, and you get the code, you copy it out. And I think writing out data sets, I don't know if it's directly seen as like, wow, like, okay, that's nice, I could put it back out to Excel. But it's not just like, okay, I changed the data set, I manipulated it, and I gave it to someone else in the CSV or something like that. As we go forward, like we were going to be able to turn a lot of things into a rectangular data set or tibble, right? So you don't really need to understand the distinction between a tibble and a data frame, other than they print differently, they look a little bit different, but they both contain rows, columns. Each column can have a different data type. It's just tibbles are nicer for printing. They don't have room. They things about them. But as we go forward, when we make models and things like that, like it's going to be very easy to turn a model into a tibble, where the rows are, this is the term, the column would be like the beta estimate, the column p-value, all that kind of stuff. And then we'll be able to manipulate those like any other data frame, like subset rows, like we only want this term. We can bind them together, where like, let's say you ran 5 different models, and you can make a whole big table with 5 different columns, we'll like put them together. And then when the write functions, the write CSV, the write that kind of stuff, that can be very important because you're usually giving that to somebody else to turn into like a pretty table, or somebody just wants to data coefficient, stuff like that. That's what I think some of these export functions, export CSV functions, are really powerful at. And as you go forward, if you work in Stata or SAS, I will say some of the things that are like just nightmares is sometimes getting exactly the thing you want, where you want it, or how you want it. So I think before when we showed like vectors and scalars and all that kind of stuff, it's like, all right, I'm just reading in data and I'll be manipulating that. That's true. But as you go forward, sometimes you want like a very customized thing. I want like X to be the p-value for this coefficient in this model, and I want to print that out somewhere. Right? In Stata or SAS, it's very hard to do that. It's very hard to extract that row, that column, that thing, because in Stata and SAS, those objects don't kind of exist. Or they'll exist in that they'll be like, all right, here's like 4 pages of model estimates. Right? Things like that. So as you go forward, right, mostly everything will be a data frame, a data set, or a tibble. We're going to use those terms kind of interchangeably. But we're going to be able to manipulate objects like models into those types of things, right? So it'll be a lot clearer once we actually fit them all and then turn it into like a table of estimates and p-values and all that fun stuff. But what we're saying is, the way I see analysis, you read the data in from some sort of raw source, usually a CSV or some of these, right? And the fact that you can do it directly from SAS or Stata or SPSS is great, because then you don't have to like do any other weird manipulation outside of R. You read it directly in, you do anything you want in there, and then output the table of results or the model results or the subset data set with the criteria that you wanted. And then it's all done within one system. You don't have to like hop around here to there to there. You don't have to ever go into Excel, because I don't know if you've ever noticed, if you open a CSV in Excel that has like a column that's like 1-2, that's like a column, like sometimes that's like an ID or something. Excel like tries to help in like the worst way possible. It's like, oh, that means like January 2nd. That does not mean January 2nd. I don't know why you would do that. And then you output it to a CSV again. Now there's kind of like January 2nd, like 1970 or something. So it's good to just kind of go from raw data into R and output whatever you want, rather than trying to mix and match systems sometimes. And especially when you have collaborators, it's like, you get these CSV, like, I want to save a data set. It's like, okay, I can do that. But I think it will be clear, but I would say if you're doing importing data right now, starting out, the drop-down menu is probably your best bet.
Today was also the most talking we'll do in this class. I think there's a lot more labs interspersed, so it makes it a little bit more concrete. I think we go till 11:50 or noon. 11:50. Okay, so then maybe we'll start tomorrow then with the lab. I guess I'll just cover the last few slides here, and then we'll do the lab tomorrow morning. The last few slides just talk about other ways of saving data. So maybe if you want to write these intermediary R-style formats, you can do that too. There's a few functions for this. One's called these RDS objects, or these R data. I don't know what the actual S stands for, but there's a write underscore RDS function that'll take an R object and give it a path to your computer, and that'll save this RDS. This can only save one object. If you want to read it back in, you have to use the read underscore RDS function, and then you need to assign it to some variable. And so there's this function identical, which tells you if 2 R objects are the same. And so if I just, save the version of it and then write it back in, I just confirm that the original one and the new one are identical. And so that's useful for one thing. I don't really use this very much. The one I use more is one called save, which can basically save a set of R objects into an R data file. with the extension .rda or .rdata. And so I can save like a variable 5. I can read in the youth tobacco survey data, and I can save both of these things together into an RDA or RData file. That's nice too, because then I can read this back in, and it will read in. And so, for example, if I list everything in my workspace, I have all these objects. I can remove certain things if I want to, and then when I load it in, they get read into my workspace directly. There's also a verbose option for doing this where it'll tell you all the items that got read in, which is nice. And so sometimes I'll save, like if I have a script that takes like a data run that like processes data, and then I have another script that analyzes it, I'll typically do all the processing and save them as like an RDA file or RData file. Then my analysis script will like read that in and do the actual analysis. And so this is nice because you can save like formulas, you can save functions, you can save R objects, etc., in sort of just one file format. And if you just print it, it'll actually tell you as a character vector what are the things that got loaded in. And again, just to summarize, like this is how you can use read.delim and read.csv, which we don't recommend, but this just gives you exposure to why you would or wouldn't use it. Where the idea is like read.delim has slightly different syntax, like using headers for row names, and this as.is, which relates to how they treat character vectors as these things called categorical variables called factors. I would say, again, many online resources use base R tools, but RStudio has switched to using Reader as sort of the default, so we've been using that. But you yourselves, if you've already used some R in the past, have always used read.csv, you don't need to switch or anything. It'll basically read in the same thing, but the idea is you can just do whatever you feel most comfortable with.
So I'll say, like, for a lot of data sets, I use CSV back and forth, but the nice thing about an RDS or an RDA, RDS for like, I think it's R data set or serialized R object, doesn't matter, but I'm saying RDS contains one thing only. RDA can contain a whole bunch of stuff. But the nice thing about an RDS, even if you're working with data sets, like let's say you have a categorical variable and you set the limits to be something, right? It's ordered in this way. If you write that out to CSV, all that stuff's gone. All that information is kind of not about the data, it's attributes of the data. So if you save an RDS out and you read it back in, those levels are kept the same, all that stuff's good. Also, sometimes it's not super simple to get certain things into a data frame, right? So CSV, although you can get the coefficients of a model, that's fine, that's great, which you can do, that's really for reporting. But when you want to save a model out, you want to save it as an R thing, so when you read it back in, you can do prediction or get plots about the model fit and all that kind of stuff. And if you turn it into like a CSV, you can't really do that anymore. So there is some utility to our data formats other than like if you're inputting output data. For data sets for the most part, if you feel like most comfortable with CSV or Excel, fine. Read and write those back out over and over again. That's not a big issue. These R data sets and our data formats become a lot more important when you start customizing the data or adding additional attributes, or if the object you're trying to save doesn't make sense as a data set, doesn't make sense as a CSV.
Cool. So yeah, we'll end right there. We'll start the lab tomorrow, and then we'll just continue on with the order of the class.
I will say, because I think the registrar asked us to do this, if you're like not sure you're going to take this whole class, I think the last day to add drop is today. I think it's very short on that time frame. So if you have like, if you're taking another class, you're not sure it's going to be worthwhile, just registrar.
Yeah.
And then
So if you go to Creative Commons, it's going to be these modules.
it should be a new
It should be dropped.
Yeah, that's what I'm just gonna see. So I have a lab specifically.
From here now, right? So once Andrew uploads, stop the recording and
Good call. Yeah.
so I have at least the majority.